Hello, kids. I'm Miss Roberta, and today we'll be reading The Fire of Stars, the life and brilliance of the woman who discovered what stars are made of. Wrapped in a blanket of sparkling space, an unformed star waits for its bright future to begin. Cecilia kicks and cries until her mother sets her down so Cecilia can feel with her own tiny toes the cold and crackly snow, which isn't soft and warm like she expected. It's the first time Cecilia learns things aren't always as they seem. In a cloud of dust and dirt, Cecilia spends hours watching slimy slugs glide through the garden and making friends with trees and flowers. There in the grass, there comes a sudden jolt, a sudden surprise. Cecilia realizes all by herself why an orchid has a petal like a bee's belly, like a bee's stomach. To trick the bees, of course. They buzz over to say hello to their pretend friend, then fly off with pollen-stuffed pockets, the start of new seeds. Cecilia buzzes too, her body humming with that lightning bolt of discovery. She wants to feel that way forever. Yet the fields and flowers, so full of inspiration for Cecilia, are not enough for her family. Soon everything shifts and separates. Mother trades the soil and starry country skies for the sooty smokestacks of London, where Cecilia's brother Humphrey can attend a better school. Cecilia is forced to say hello to city streets full of strangers and goodbye to the company of trees and bees, and the change is crushing. Shrinking and smashing, and Cecilia's sphere feels smaller and smaller still when she realizes her new school is a black hole with none of her favorite classes. No algebra, no German, no science. Not even any friends for a shy and studious girl like her. Yet deep inside, something glimmers and glows. Cecilia hides in a secret place, a dusty lab meant for older students, and studies the rows of chemicals ringing the room all around the room. There are pieces that put the universe together. At home, she makes friends with her family's books on plants and Newton's laws of motion. In her heart, Cecilia crams every empty space with this kindling light, science. Slowly, companions join the star to be. Miss Dalglish, a science teacher, appears in Cecilia's orbit, a new friend. She sweeps into school and blows away Cecilia's loneliness. Together, they take garden walks and talk of leaves and flowers. At Christmas, Miss Dalglish gives Cecilia her very own book on astronomy, on the study of stars. Cecilia shines with joy, but Miss Dalglish grows so sick, she has to leave the school. So the light dims, compressed. Loneliness creeps in again, but Miss Dalglish writes Cecilia letters telling her to stick to her path, and Cecilia does. She becomes a stellar student and wins a scholarship to study plants at the University of Cambridge. She chases new ideas like butterflies, yearning to feel that lightning bolt of discovery again. Yet, her teachers want her to learn only the facts, to notice nothing new. Bottled up, the energy of her mind has no escape. But it doesn't disappear. Heat builds up inside, pressure growing, never slowing until Cecilia hears a talk by astronomer Arthur Eddington. His work is an incandescent combination of astronomy and physics, a brand new field to study, astrophysics. Cecilia feels a jolt, that lightning bolt again, and her brain buzzes with the possibility of new things just waiting to be discovered. From memory, she scribbles down every word Eddington said. Then, she switches her studies to physics. In physics class, Cecilia is the only woman in a galaxy of men. The professor and other students tease her, and Cecilia shrinks, but she won't be stopped. And by graduation day, she's fully formed. A star, a scientist, ready to unlock the mysteries of the universe. So when she learns Cambridge has no place for a woman astronomer, she forms another plan. A boat ticket, a trunk filled with all her belongings, and a job in America. At the center of a new solar system, Cecilia is now ringed by a circle of real friends, other women working in astronomy at Harvard. Cecilia spends hours in the observatory studying star ingredients, wondering what stars really are. Are they made of the same stuff as Earth, as so many scientists think, or something else entirely? But they kept their recipe secret. As months passed, Cecilia's hopes of solving the mystery shatter and shrink. The heat grows. The observatory director asks her to write up her results, but she's not ready yet. Not yet. But deep inside her, something glimmers and glows, growing stronger. Something new, and then at last, a new light. Cecilia blazes with that lightning bolt of understanding. Through her careful calculations and hours of observation, the rainbows of starlight share their secrets with Cecilia. They show that stars are mostly hydrogen and helium, not like the rocks and minerals of our spinning planet. It's a stellar discovery, breathtaking, but best of all, it means other questions are rising on the horizon. If this is what stars are made of, how do they form? How do they create such enormous energy? And whose will the next discovery be? Do you think it's you? Cecilia Payne, a science superstar. The reward of the young scientist is the emotional thrill of being the first person in the history of the world to see something or to understand something. In 1925, when she was just 25 years old, Cecilia Payne discovered the exact recipe for what makes the stars. She was the first person to know. Since ancient times, men had guessed that the earth and the sun were made of the same ingredients. But how could they determine how much of each ingredient the stars contained? Well, Cecilia found a way. For her thesis, she studied star rainbows, known as spectra, preserved on thousands of glass plates at Harvard. Spectra are created by passing starlight through a spectroscope, which separates light into bands of color from red to violet. You might see a similar rainbow when sunlight shines through your window at just the right angle. Each star spectrum is cut by a series of dark lines created when atoms absorb light. By examining how light or dark the lines appeared, Cecilia was able to calculate the temperatures of different stars and determine how much of each element they contained. Her results stunned the astronomers of her time. They shocked her. Who thought the composition of the stars was similar to that of Earth? Yet, stars are far different. Mostly hydrogen and some helium, with only a sprinkling of Earth-making element. In fact, hydrogen and helium are the most common elements in the entire universe. At first, Cecilia couldn't believe what she had found. But other astronomers soon arrived at the same conclusions. They found the same things. Cecilia's findings paved the way for astronomers to learn how stars burn bright. Today, we know their power comes from slamming together hydrogen atoms, creating helium and releasing tremendous energy. Cecilia's results also laid the groundwork for much of what astronomers know about how stars are born, grow old, and die. As a woman working in science, Cecilia often found her path difficult. She didn't look like other scientists of her day. They were mostly men. But Cecilia proved not only what makes a star, but also what makes a star scientist: curiosity, passion, hard work, and belief in oneself. So this is how a star is born. Wrapped in a blanket of sparkling space, an unformed star waits for its bright future to begin. Space looks empty, but it's not. In the empty space between star systems sit massive clouds called nebulae, made of hydrogen atoms and bits of dust from dead stars. The hydrogen atoms each have the tiniest amount of gravity and are attracted to each other by that tiny amount. Yet, the atom's gravity is so weak and the particles are so far apart, they don't pull together yet. In a cloud of dust and dirt, there comes a sudden jolt. For stars to form, astronomers think an outside force starts the hydrogen atoms moving. This could be an old star exploding nearby, or a new star forming. These events send shock waves rippling through space, unsettling the cloud and now moving the hydrogen atoms closer and closer together, where gravity can do its work. Then snap! Just like magnets, the hydrogen atoms start clumping up. Soon, everything shifts and separates. As the hydrogen atoms clump together, the massive cloud splits into fragments. A single cloud can break up into thousands of smaller clouds, and each smaller cloud can form a star. This is why stars are often part of star groups or clusters. Shrinking and smashing, the cloud fragments continue to shrink as the hydrogen atoms' gravity pulls them closer and closer together. A cloud fragment that ends up packed into space the size of our solar system could start out 100 times bigger. Eventually, the center of the cloud fragment starts to heat up as those tightly packed atoms keep energy from escaping. Yet deep inside, something glimmers and glows. After tens of thousands of years, the center of the fragment cloud heats up to about 10,000 Kelvin, hotter than any furnace or oven on Earth. A protostar, or baby star, has formed. Through the years, the protostar continues to grow hotter, and it starts to spin faster and faster as it contracts, like an ice skater who spins more quickly when they pull in their arms. The swirling gas and dust around the center flatten out, forming a disk like Saturn's rings. By this point, the protostar's center can be 1 million Kelvin, which is very, 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 very hot. Slowly, companions join the star to be. Meanwhile, planets form from the gas and dust in the disk. Just like hydrogen atoms, the gas and dust attract each other. Over time, they clump together, growing bigger and bigger and eventually forming planets. You might wonder why the gas and dust don't get pulled into the star. Well, they are far enough away that the gravity is too weak, just like Earth is far enough from the sun to stay safely in its own orbit. The light dims, compressed. As the protostar continues to form, it glows less brightly. That's because the protostar is compressing smaller and smaller in size. But at the same time, the protostar keeps growing hotter, reaching 5 million Kelvin. Powerful winds made of gas particles sweep its surface and blow out into space. The wind clears away any remaining gas and dust around the protostar, making it easier to see. But it doesn't disappear. Heat builds up inside, pressure growing, never slowing until, finally, a star. Once the protostar's center reaches 10 million Kelvin, the heat and pressure are so great that the hydrogen atoms squish together in a process known as nuclear fusion. During fusion, the star turns hydrogen into helium and gives off lots of energy. the protostar has finally become a star. At the center of a new solar system, the heat grows, and then at last, a new light. Nuclear fusion provides the heat and light we need for life on Earth. Forming a star as massive as our sun can take 50 million years or more. Once formed, such stars may live for 10 billion years before running out of hydrogen and dying out. So this is the timeline of Cecilia Payne. Cecilia Payne is born in Wendover, England to Emma and Edward Payne. Edward Payne is a lawyer and historian with a large collection of books, which Cecilia reads. She is the oldest of 3 children. In 1904, Cecilia's father dies. In 1912, Cecilia's mother moves the family to London so Cecilia's brother Humphrey can attend a better school. Cecilia leaves her country school for a religious one, where there is little time for science and other subjects Cecilia loves. In 1915, physicist Albert Einstein presents his general theory of relativity. If his theory is correct, the gravity of massive objects like the sun should bend light rays nearby. In 1919, Cecilia graduates from high school and enrolls in Newham College at the University of Cambridge, focusing on botany, the study of plants, like her Aunt Dora, who worked with Charles Darwin. Cecilia hears Professor Arthur Eddington's talk in December, where he discusses the images he took of a solar eclipse. The picture shows starlight bending as it nears the sun instead of following a straight line, just as Albert Einstein had predicted. Cecilia is not allowed to change her studies to astronomy, so she focuses on physics and sits in on as many astronomy classes as she can. Eddington encourages her. In 1920, Arthur Eddington, building on the work of F.W. Aston, publishes a paper suggesting fusion of hydrogen might be the source of the sun's energy. That same year, Indian astrophysicist Meghat N. Saha publishes his equation of thermal ionization, which Cecilia will later use in her thesis work. Cecilia completes her studies in physics and receives money for further studies at Harvard with its collection of stellar spectra. In 1925, Cecilia earns a PhD for her work at the Harvard College Observatory. Radcliffe, Harvard's sister school, grants her degree because women technically cannot attend Harvard. It's the first PhD in astronomy awarded based on her work from the Harvard College Observatory. Cecilia publishes Stellar Atmospheres, the first of her 9 books and 351 papers. In 1927, Cecilia becomes technical assistant to the Harvard College Observatory director, a position she holds for more than 10 years. Men with her education would typically be college professors. In 1929, Henry Norris Russell, one of the most famous astronomers of the day, confirms Cecilia's conclusions about the amount of hydrogen in the stars in a paper he publishes. When he first read Cecilia's work in 1925, he had said her results were clearly impossible. He barely mentions Cecilia's results in his paper. Cecilia learns a lesson, saying later, "If you are sure of your facts, you should defend your position." In 1931, Cecilia becomes an American citizen. Cecilia is the first to win the Annie Jump Cannon Award for Exceptional Women Astronomers in 1934. She marries fellow astronomer Sergei Gaposchkin, originally from Russia. They work together on many projects and eventually have 3 children who play hide-and-seek around the Harvard College Observatory. In 1938, Cecilia is appointed astronomer at Harvard University. In 1956, Cecilia becomes an astronomy professor and chair of the astronomy department at Harvard. She is the first woman at the university to serve as the head of a department. In 1976, Cecilia receives the Henry Norris Russell Lectureship for a lifetime of excellence in astronomical research. And in 1979, Cecilia dies at the age of 79. And that is the end of our book. Thank you very much for reading with me. Bye-bye.